here and look and see if we can cover those 5 points. And I just want to remind you what those 5 points are for. U, D, R, S, S. Units, data, relationship, substitution, and solution, or solving the problem. So let's first of all look at the data here. The data is the things we know, things that are given to us in the problem, and the stuff that we don't know, the stuff we're looking for. So in this problem, let's look for the things we know. Here we have 2.5 grams of silver. So we're going to write that down as something we know. 2.5 grams of silver. Let's see if there's anything else we know in this problem. Let's see, 2.5 grams of silver with a ratio of mass to volume of 10 grams per milliliter is placed in a graduated cylinder that initially contains 11.2 milliliters of water. What will the volume of the water read? Well, there are some other things here we know. This is an important piece. We're going to jot it down. 10 grams per 1 milliliter. That really also means that 10 grams equals 1 milliliter. That kind of looks like a conversion factor now. And we have 11 milliliters of water. That's another thing that we know, 11.2 milliliters of water. Now, the thing we don't know is at the end, after we've added this together, what will the volume of the water read? What is the final volume in milliliters? Now it's often helpful in this kind of a problem to draw a picture to kind of show what we're talking about. So here I'm talking about this instrument that hopefully you've experienced before. It's called a graduated cylinder. Has marks along the side so you can tell the volume. And into this graduated cylinder, we're going to put some water. And we know that the volume of this water is 11.2 milliliters. That's what we know to start with. Trying to get out here and get this computer to do some of its magic for me. Let's see if I can copy that and paste it. Oh, look at that. It worked for me. Okay. So we've got this same graduated cylinder. And into this graduated cylinder, we are going to place some water, but we're also going to put in a piece of silver. And we want to know how much, when we add that piece of silver, the volume, of course, is going to increase. What will this new volume be? That's what we're really asking. So what have we covered here so far? We have placed, we've found our data. This is our data right up here. In fact, all of this stuff is under data. And now we're going to think of our relationship, and we're going to be careful in our relationship to include units. So we have here 2.5 grams of silver. That's what we're starting with. If we just knew the milliliters of silver, we would be fine. Well, look, it turns out we do have a relationship between grams of, I didn't write silver here, did I? Grams of silver and milliliters of silver. And we can use that relationship here using our factor label method to make the grams of silver disappear and milliliters of silver be our new unit. Look at that. We can do this. And this tells us that we have the number that goes with milliliters of silver is 1. So 1.0. The number that goes with grams of silver is the 10. 10 grams of silver. And we do 2.5 divided by 10. That gives us 0.25 milliliters of silver. Now, if we add that to the 11, I'm just going to go down a little bit here, just a little. If we add the 11.2 milliliters of H2O and the 0.25 milliliters of silver, we will now have a total of 11.45 milliliters. That is this volume. Now, let's go back through here and look. The relationship. The relationship in this problem is this relationship that allowed us to make our units cancel out. That's the points you're going to get for the relationship points right there. The substitution is where we've put in the numbers from our conversion factor. This 1 right here and this 10 from right here. We've substituted those in. That's the point for substitution. And then, of course, the solution, the part we're all excited about getting here at the end, the solution point. That would be the 5 points for this problem.